вброс. Экипаж одевает защитные очки. Осталось 3 секунды. 2, 1, 0. Взрыв сопровождался световой вспышкой необычной силы. В этот момент самолет-носитель находился в 40 и последующие свечения, несмотря на сплошную облачность, были видны в радиусе до... Пылевой столб, поднимающийся с земли, быстро увеличился в объеме. Через несколько секунд после взрыва диаметр пылевого столба составлял около 10 километров. Увеличиваясь в размерах, облако медленно поднималось вверх. В своем конечном развитии оно достигло высоты 60-65 километров.
Imagine a force so immense, a cataclysmic event that redefines the very meaning of destruction. It eclipses every explosion in human history, dwarfing even the most devastating wartime bombings and industrial accidents. Think of the largest explosions you've ever witnessed, then multiply that by an unimaginable factor. This is Tsar Bomba, the king of bombs, the most powerful nuclear weapon ever detonated, a testament to human ingenuity and a stark reminder of our capacity for destruction. Detonated by the Soviet Union on October 30th, 1961, in the desolate Arctic archipelago of Novaya Zemlya. This remote location was chosen to minimize the impact, but even there the effects were earth-shattering. It unleashed energy equal to over 50 million tons of TNT, a figure so large it's difficult to comprehend. That's 10 times the combined power of all World War II explosives. Imagine every bomb, every shell, every explosive device used during the entire war, and multiply its destructive force tenfold. Its flash was seen over 1,000 kilometers away, a blinding pulse of light that pierced the Arctic sky. And its shockwaves circled the Earth 3 times, a testament to the sheer power unleashed. Seismic instruments around the globe registered the event, a clear indication of the bomb's unprecedented yield. The mushroom cloud soared 64 kilometers high, reaching into the mesosphere. That's 7 times taller than Mount Everest, a visual representation of the bomb's unimaginable scale. This was more than a military test, it was a global statement, a deliberate display of Soviet power during the height of the Cold War. A chilling demonstration of Cold War brinkmanship, pushing the world to the edge of nuclear annihilation. Tsar Bomba wasn't just a bigger bomb, it was in a league of its own. It was a leap into a new realm of destructive potential, showcasing the terrifying advancements in nuclear technology. Its creation was as much about politics as it was about science, a tool of diplomacy and intimidation in a world teetering on the brink. A product of the fierce rivalry between the US and the USSR, a symbol of the nuclear arms race that defined the era. Understanding Tsar Bomba means understanding a moment when humanity's survival seemed to hang in the balance, a time of unprecedented fear and uncertainty. As we explore its science and legacy, we must ask ourselves critical questions about the nature of power and responsibility. What did we learn and how does it guide us today as we navigate the complex challenges of nuclear proliferation and global security? The Cold War split the world into 2 camps. Capitalist America and Communist Soviet Union locked in a relentless arms race. Each side believed that bigger, more powerful weapons would deter the other, a doctrine known as mutually assured destruction. Under Premier Nikita Khrushchev, the USSR felt pressured to outdo the US in nuclear might. Khrushchev demanded a bomb so powerful it would shock the world and prove Soviet supremacy. Thus, Tsar Bomba was conceived not as a practical weapon, but as a psychological and political tool. The project was rushed to coincide with a major Communist Party Congress, putting immense pressure on Soviet scientists. Figures like Andrei Sakharov led the effort, driven by patriotism, scientific ambition, and the belief that their work was vital for national security. Tsar Bomba's creation was fueled by both top-down orders and the momentum of a nation determined to make history. Building Tsar Bomba, a weapon of unparalleled destructive capability, was an undertaking that demanded the best minds and resources the Soviet Union could muster. It meant overcoming unprecedented scientific and engineering challenges. The sheer scale of the project required innovative solutions and a willingness to push the boundaries of existing technology. The original plan called for a 100 megaton bomb, a force that could reshape landscapes and redefine the meaning of devastation. But concerns over fallout, the invisible killer that lingers long after the initial blast, led to a scaled-down 50 megaton design. This reduction aimed to mitigate some of the environmental consequences, though the weapon remained terrifyingly powerful. A key innovation was replacing the uranium tamper with lead, a decision that had profound implications for the bomb's overall impact. This dramatically reduced radioactive fallout, lessening the long-term contamination of the surrounding areas, and making it relatively a clean bomb for its size. This meant that while the immediate destructive power remained immense, the lingering radioactive effects were somewhat lessened compared to a bomb of similar yield using a uranium tamper. The bomb itself was colossal, a true behemoth of destruction, 8 meters long, dwarfing almost anything else that could be carried by an aircraft. Over 2 meters wide, a diameter that challenged the limits of aircraft cargo bays, and weighing 27 tons, requiring specialized equipment just to move it. No Soviet bomber could carry it internally, highlighting the unprecedented scale of the weapon. So a Tu-95 was modified, a testament to the lengths the Soviets were willing to go to test this weapon. To haul it semi-externally, protruding from the aircraft's belly, a clear indication of its immense size. Safety was paramount. Given the destructive potential, every precaution was taken. A massive parachute slowed the bomb's descent, buying crucial time for the crew to escape the blast radius. Giving the crew precious minutes to escape, a race against the clock and the impending explosion. Both planes were painted white, a measure designed to protect them from the intense thermal radiation, to reflect the searing heat of the blast, minimizing the risk of damage to the aircraft. Every detail from delivery to detonation was meticulously planned, leaving nothing to chance. Was meticulously planned, ensuring the mission's success and the safety of those involved as much as possible. The result, a weapon that pushed the limits of what was physically and morally possible, a stark reminder of humanity's capacity for both innovation and destruction. Tsar Bomba was a feat of engineering, a testament to Soviet scientific prowess and technological capabilities, and a warning to the world, a chilling demonstration of the potential consequences of nuclear war. To grasp Tsar Bomba's power, we need to understand the basics of a hydrogen bomb. Unlike atomic bombs, which use fission, hydrogen bombs use a two-stage process. A fission explosion triggers a far larger fusion reaction. The primary fission stage creates X-rays that compress and ignite the secondary fusion stage using lithium deuteride as fuel. This process, called radiation implosion, creates temperatures and pressures like those in the sun. In Tsar Bomba, over 97% of the yield came from fusion, making it both powerful and, for its size, relatively clean. The use of a lead tamper capped the yield at 50 megatons and limited fallout, but the Soviets could have made it twice as destructive. Tsar Bomba was a demonstration of both technical mastery and restraint, terrifying proof of what was possible. October 30th, 1961. A date etched in the annals of history. A day when humanity dared to unleash a force unlike any other. The location, Mityushika Bay, Novaya Zemlya, a remote and desolate archipelago in the Arctic Ocean. This isolated Soviet testing site was chosen for an event that would send shockwaves across the globe. The world's largest bomb, a behemoth of unimaginable power, was about to be tested. Codenamed Tsar Bomba, this device represented the pinnacle of Soviet nuclear ambition. A modified Tu-95 bomber, a strategic aircraft repurposed for this singular mission, was piloted by Major Andrei Durnovtsev, a man entrusted with delivering this unprecedented weapon. Strapped beneath its belly was Tsar Bomba, a symbol of Cold War tensions and the terrifying potential of nuclear technology. Trailing closely behind was a Tu-16 observation plane, tasked with recording the cataclysmic event and gathering crucial scientific data. The bomb was dropped from an altitude of 10.5 kilometers, a height calculated to maximize the blast's impact and minimize the risk to the aircraft. As it fell, a massive parachute deployed, slowing its descent and buying the crew precious time to escape the impending blast radius. Every second counted. At precisely 11:32 a.m., the countdown reached zero. Tsar Bomba detonated 4 kilometers above the ground, unleashing a force equivalent to 50 megatons of TNT. The resulting fireball was a colossal 8 kilometers wide, an incandescent sphere of unimaginable energy. The flash from the explosion was visible over 1,000 kilometers away, a stark reminder of the destructive power unleashed. Even at a distance of 270 kilometers, observers felt a heat pulse, so intense it was strong enough to cause burns, a testament to the sheer energy released. The mushroom cloud, a terrifying symbol of the nuclear age, soared to an astonishing 64 kilometers into the atmosphere. The cap of the cloud spread to a width of nearly 100 kilometers, a dark and ominous presence dominating the sky. The shockwave generated by the blast reverberated across the region, shattering windows in both Norway and Finland, a clear demonstration of its far-reaching power. Buildings within a 55-kilometer radius of ground zero were completely leveled, reduced to rubble by the sheer force of the explosion. The seismic waves generated by the blast were so powerful that they circled the entire globe not once but 3 times, a chilling reminder of the bomb's global impact. Even the mighty Tu-95 bomber, designed to withstand significant turbulence, was rocked violently by the blast, dropping a kilometer in altitude despite its best efforts. The test was more than just a demonstration. It was a spectacle of unimaginable power, a display of raw, destructive capability that captivated and terrified the world. It was a moment that redefined the very limits of destruction, forcing humanity to confront the true potential of its own creations. After that day, the world would never look at nuclear weapons the same way again, forever changed by the shadow of Tsar Bomba. Tsar Bomba's detonation was both a show of force and a scientific experiment. Its yield, 50 megatons, was confirmed as the largest man-made explosion ever. The bomb's design, with its lid tamper and fusion-heavy yield, produced far less fallout per megaton than previous bombs. The atmospheric shockwave circled the globe, and the explosion disrupted radio communications for hours. Scientists gained invaluable data on shockwaves, mushroom cloud formation, and atmospheric effects. Politically, Tsar Bomba was a clear message. The USSR could build weapons of almost unimaginable power. The test escalated Cold War tensions and forced the world to confront the terrifying reality of nuclear escalation. Over time, myths have clouded the story of Tsar Bomba. Its maximum design was 100 megatons, but the tested version was deliberately scaled down to limit fallout and risk. While called clean for its size, no nuclear bomb is truly clean. Tsar Bomba still released significant radioactive material. The lead tamper reduced long-lived fallout, but fusion reactions still produced some radioactive isotopes. Andrei Sakharov, a key designer, later became a vocal critic of nuclear weapons and won the Nobel Peace Prize for his activism. The test site was remote and evacuated, so there were no direct casualties despite the bomb's apocalyptic potential. The real horror lies not in the test, but in what could have happened if such a bomb were used on a city. Tsar Bomba's legacy is a warning, not a myth. Tsar Bomba's detonation sent shockwaves through global politics and the human psyche. It forced the world to confront the reality of weapons capable of annihilating humanity. The bomb's sheer scale helped spur arms control efforts, including the 1963 Limited Test Ban Treaty. Tsar Bomba provided scientists with data on atmospheric and environmental effects, fueling research into nuclear winter and the dangers of large-scale war. Its legacy is one of awe and caution, a symbol of the peak of Cold War nuclear insanity. No bomb of its size has been tested since, but the knowledge remains. Tsar Bomba stands as a monument to the responsibility that comes with scientific power. It urges us to choose peace and restraint over destruction. Decades later, Tsar Bomba's lesson is clear. Human science can unlock unimaginable power, but at what cost? Its creators, like Sakharov, later recoiled from its implications, highlighting the moral burden of such knowledge. The bomb was born from Cold War fear and rivalry, a product of geopolitical pressures. Its existence fueled the movement for nuclear disarmament and made the case for arms control undeniable. Tsar Bomba became a symbol for peace activists and a warning to future generations. Its shadow reminds us that vigilance against nuclear proliferation is never ending. The story of Tsar Bomba is a timeless lesson in the dual nature of scientific progress. capable of creation and destruction. As we face new technological frontiers, its legacy urges us to channel human ingenuity toward peace, not annihilation.